Let's talk about two different ways of doing this question. So we've got that the first class stamps are 85p and the second class is 66. We're going to buy some number of each because we're buying at least one of each type. And when we buy them, we have to spend an exact number of pounds. So that is, it's going to be a multiple of 100 pence. Now, we can just look at the numbers and sort of think about the different ways of doing this. Well, if I buy one or three or five first class stamps, then this is going to end in a five. And there's no way that I can then combine that with any number of second class stamps because I can never get this one to end in a five. So basically F has to be an even number. And maybe I try buying two, 170. Meanwhile, I've then got to try and make this one end in a zero. So it's not going to work if I buy two or three or four, but it is going to work if I buy five. So I'm just going to calculate how much it will cost to buy five, and that'll be 330. If I add those two together, I'll get 500. And I feel like that's quite convincing that that is going to be the smallest number, especially because it's there in the answers 7. So that's basically how I did it. Just sort of logically think about it. You can just use a complete trial and error method, but it helps to like think about it a little bit and think, actually, yeah, this has got to be a multiple of 2 and this has got to be a multiple of 5. So I'm going to talk about a second method. It kind of works in the same sort of way, but it's a bit more general, and that is to write it as an equation. So it must be that 85, so this is method 2, that was method 1. It must be that 85 times the number of first class stamps plus 66 times the number of second class stamps is equal to 100 times some integer. Now this is actually called a Diophantine equation after a Greek mathematician who was interested in solving equations like this, which had integer solutions, which is what we're looking at here. Now, if we make 85f the subject, then we note that this one is always divisible by 2. I could write it as 2 50n minus 33s. They don't have any other common factors necessarily. But 85 is not divisible by 2, so that necessarily means that f must be divisible by 2. It's working out in a similar way to how I justified this above. And then we can do the same with 66s. It's going to be 100n minus 85f. And this now has a common factor of 5. But 66 does not, and therefore s must be divisible by 5. And then it makes sense to, that won't guarantee that 2 and 5 will be the smallest solution, but those would be the ones to then check first. And then you might say, if that didn't work, of course it does work in this case, and we're sorted. You might try 4 and 5. You can sort of have a little go at it. Or of course 2 and 10. There could be lots of different options. But in this case, because we're interested in the smallest ones, we check this one. It does indeed lead to 500 pence, so we're done.